In this lesson, we're going to be taking a look at how to rewrite quadratics that are in standard form and put them into factored form. And I'm actually starting you off with the factored forms here because that's what this is. This is the factored form that we're going to be working toward later today. But the whole idea of what we're doing is we're writing an equivalent expression. And so I just want to reemphasize how this works and why it actually is equivalent. So if I were going to be multiplying this out like it's asking me to, I have to multiply the x by the x, then the x times 5, then the 3 times the x, and then the 3 times the 5. Because multiplying sets of parentheses, you multiply everything in the first parenthesis by everything in the second parenthesis. When you do that, we end up with this, and then we combine our like terms. And you'll notice I have a couple terms here that just have the x in them. And so I combine them to get here. And so in these examples, I'm starting with the factored form and I'm writing it in standard form. Again, here very shortly we're going to go the other direction. But I want us to have some examples that we can build off of so that we can see why it works the way it does. And that's what we're going to be developing here. So let's go ahead and do the same thing for 2 and 3 very, very quickly here. So in number 2, if I multiply everything in the first parenthesis by everything in the second parentheses, I end up with x squared minus 9x plus 14. Repeat the same process for number 3. And now I have all my answers. Now, what we're looking at here is a set of equivalent forms. Equivalent forms mean that that expression right there will always give us the exact same results as that expression. For instance, if I turn them into equations and graph them, the graphs would look identical in every way. If I started plugging numbers in for x, I would get the exact same value out of it, whichever form I used it. So why do we care about having another form? Well, you'll find that some are useful for one use and some are useful for another use. So it's going to just make our lives a little bit easier to be able to see each one because each one comes up in its own little scenario there. And the same is true for all of these. These are equivalent forms here in number 2, so yes, they are exactly the same. And in number 3, these are also equivalent. So what we want to do then is we just want to be able to manipulate these and make them look like another form when we need to have a particular application. And so, using what we've done here, I'd like you to look and see, can you identify the pattern here? And if you need to pause the video in order to go and take a moment and look them over to see if you can find the pattern, by all means do so. But I'll give you a moment here. All right, so do you see a pattern between the 3 and the 5 and, for instance, the 8? I hope so. Because 3 plus 5 would equal 8. So if I added them, I get the 8. What about the 15 over here? Is there a relationship between the 3 and the 5 and the 15? Well, yeah. 3 times 5 is 15. Does that work for the other two as well? Take a quick look. Hopefully you're saying yes. Because negative 7 plus 2 does add to be negative 9. And negative 7 times negative 2 is a positive 14. And the same thing happens here in number 3, where negative 2 plus 5 is a positive 3, and negative 2 times 5 is a negative 10. And so then we see a pattern here, where in our standard form, our factored form numbers add to give me the middle number, and my factored form numbers multiply to give me the last number. Now, there's a couple different ways that I could have you describe that in your notes. This is the first of them. This is a very symbolic way. This is a very mathematical way of writing this rule, where we're saying, here's my standard form, and if I want to factor that, then the two numbers in the factor, for instance, m, go ahead and color code on this down, and n, my two numbers in my factor form, notice they add up to give me b, or they multiply to give me c. Well, basically that's the rule that we just talked about. And for some of you, this is a great succinct way to write this. So yeah, put it into your notes. It may well help you. And remember that you can pause the video here to write this into your notes and then resume it. But I said that for some of you, this is a good way of looking at it. For others of you, this is just a whole lot of letters. So another way you could describe this is this way. In order to factor quadratics, we ask that question. What two numbers add to the middle number, which is the b value there, and which two numbers multiply to the last number, the c? This may also be a useful way to write in your notes. In fact, I would like you to write this in your notes this way. This set of notes and the last page that I showed you, they're really saying the same thing. It's just a matter of remembering it in the way that makes the most sense to you. And so while I'm asking you to write down both, partly because one might end up being more useful on one day and the other one might be more useful to you on another day, just depending on where your brain is. But I want you to make sure that you have at least the one written down that'll work best for you, which means having them both handy just in case. Now that you have this down in your notes, and if you need to pause the video to finish, do so, we're now going to go and just practice this idea a little bit. So we're going to start by practicing it by factoring this quadratic expression. As you can see, this one is currently in standard form, and we're being asked to factor it, which tells me that we're going to end up trying to get it into a form where we have the sets of parentheses. Because factoring basically means put parentheses into it and take it as far going that direction as you can. Now, in order to do that, we need to try to figure out which two numbers add to our middle number, which is a positive 13, and multiply to our last number, which is a negative 30. Now, if I just ask you that question, what two numbers add to 13 and multiply to negative 30, you hopefully can come up with that answer fairly quickly off the top of your head. If you can, good news. All you'd have to do is plug those numbers into the parentheses, and I'll show you what that looks like in a moment. But you will hit problems at some point where it's not super easy, where you might find it, but maybe you don't. But you know it's out there. There will be times like that, because we all have our little blind spots and our challenges. And so I also want to show you a way where if you actually get stuck on one, you're like, I've checked everything, I can't find the combination. This is what I'd like you to do. When you get stuck, make a table. And in this table, what I want you to do is I want you to write out every possible way that you can multiply to the given number. Now notice, I start with the multiplying. I don't start with the adding, I start with the multiplying, because there's normally a shorter list for multiplying than there is for adding, so you'll save yourself some time and energy. So in this case, I need to multiply to a negative 30. So I'm going to list out all of the different ways that I can multiply to negative 30. Okay, there's all the different ways. And then what I need to do is I need to see what each of those combinations add to. So for instance, negative 1 plus 30 is a positive 29. By the way, a quick tip that's always good to remember, when you're adding a positive and a negative, whichever one you have more of, that will be the sign of your answer. So like in this case, we had more positives than we had negatives. Therefore, my answer was positive. And I keep going down and just figuring out what do each of these different combinations add to. Although remember, I'm trying to figure out what adds to 13. I just found that. So if I were doing this on my paper, trying to find that one combination that had eluded me, I could actually just say, oh, well, I just found it. I'm done. I don't need to keep going. Now, you might go ahead and write them all in. But if you do, it'll make it easy to figure it out. This is what we're really interested in, is that one combination of negative 2 and 15. Now, notice where those go in my factored form. Every factored form that you're going to be doing, at least at this point with these quadratics, it'll always start with two sets of parentheses. Each parenthesis will start with an x because they multiply to give us the x squared there. And then whatever our two numbers are, so like the -2 and the 15, those are the numbers that follow the x's. If it's positive, then it's plus. If it's negative, then it's minus. So you notice in this case, I ended up with x minus 2 times x plus 15. But you might be wondering, what if I switch the order? What if I had written it as x plus 15 times x minus 2? That does also work. That is also perfectly fine. What's important is what's inside of each parenthesis, and that is the same. So notice x minus 2 and x minus 2. The 2 has to be the one with the minus in it. X plus 15, notice that's a positive 15. Also, it has to be plus 15 there. The order of the parentheses themselves doesn't change anything because we're multiplying them, just as long as the stuff on the inside is the same. So having done that problem, we're now going to go take a look at 4 more. Now, each of these provides a new little opportunity to practice some subtlety of this process. I would encourage you to actually work each of them out before me. I will actually write up here what order I'm going to do them in so that you can do them in the same order. And what I would encourage you to do is try factoring every single one of them on your own. Now, if you are working through it and you get stuck at a certain point, then when you get stuck, then resume the video, watch everything up to that point, then I'll explain what we do from that point, and then you can pause the video again and continue working from that point. This is a great way to be learning, especially when we're having to go through videos like this, is you really need to take advantage of the fact that we pause, but you also do need to try working them on your own. It can be all too often where we treat a video lesson like it's a TV program. We just sit back and kind of listen to it. That doesn't really work well for learning. We have to be actively engaged with our learning, which means actually trying this stuff. Normally, if we were in a classroom, I'd just give you these problems and I'd have you working on them, and I would go around and I would look at your work and let you talk to me about them. But because we're stuck with the video, we have to actually try doing some of those things on our own. So yeah, work them on your own, pause and resume as needed. So go ahead, pause the video and start doing that, and then resume when you are done with that. All right, I certainly hope that you've actually had a chance to get at least somewhat through these problems. Let's jump in and start working them through then. So for our top left one, we have x squared plus 9x plus 20. I'm asked to factor it, which already tells me that I'm going to start with this. I always start with those sets of parentheses if I'm factoring it. Now, I need to figure out what two numbers add to 9 and multiply to 20. I'm always thinking about the multiplying part first. So I'm multiplying to a positive, and I'm adding to a positive, which means that both numbers will have to be positive inside the parentheses. Then I can just think through, okay, what are all the different ways that I can multiply to 20? 1 and 20, that adds to 21, so that's not it. 2 and 10, that adds to 12, so that's not it, although I'm getting closer. 3 doesn't go into 20, so I'm not going to worry about it. 4 times 5, which adds to 9, so I found my combination. And again, it doesn't matter if you write it as x plus 5, x plus 4, or if you write it as x plus 4, x plus 5. All right, next, I'm going to go to the top right. In this case, the most common question that comes up at this point is, what am I adding to? Well, it's all about what number is in front of that x, right? Even though it's not written in. Some people will say it's 0, but if it were 0x, we wouldn't have any x's left behind. In order for us to have an x left behind, there has to be one of them. And so that is going to be adding to a positive 1. If you got stuck on that, go ahead and factor it from there. There is our factored form. It ends up being x plus 5 times x minus 4. Next, we go to the bottom left problem. In this case, we are going to be adding to -7 and multiplying to 10. So, as you get going on these, you'll probably get very quick on them. You'll just say, okay, well, what two numbers add to -7, multiply to a positive 10? So here, multiplying to a positive, so both signs have to be the same. If we're going to add to a negative, that means they both have to be negative. Multiplying to 10, 1 and 10, nope, that wouldn't work. 2 and 5, that would work. So, x minus 5, x minus 2. Repeat the same process for the last one. In this case, I'm multiplying to a negative, which tells me 1 positive, 1 negative. And I'm adding to a negative, so I know I'm going to have more positives than negatives. Okay, so let's see, to get the 10, 1 and 10, nope, that doesn't work this time either. 2 and 5, oh yeah, the 2 and the 5 could work. I just have to make the 5 be the negative. There is my factored form, and now these are all done. Now, one last little tip, one last little hint on these. If you do find these types of problems to be particularly challenging, it probably is because you don't have your multiplication table just totally fluid. Now, it doesn't mean that you have to have it just memorized in terms of very fast answers, but you should be able to get any of these numbers out of the standard multiplication table in maybe like 3, maybe 5 seconds tops. If you have tips and little tricks to be able to figure out what is this combination going to give me, that's fine. But the goal is that you would be able to quickly think about, well, if there's some number that I'm looking for, like let's say I'm trying to figure out 24 and different ways I can get 24, that in your brain, you'd be thinking about all these different ways that 24 can crop up and kind of picturing those in your brain so that then you can start tracing them out and figuring out, okay, what goes with what? And then start doing the adding in order to be able to find that combination that gets you there. So just as a general tip, if you're rusty on your multiplication table, I would definitely encourage you to continue working on it. It doesn't just help with factoring, it helps with all of the math that you're going to be doing.